Hi everyone and welcome to Activity 22. Today we are going to talk about using our trig identities to help us solve trig equations. So previously we've worked on solving trig equations, but this time we need to simplify first using either Pythagorean identities or maybe some of the reciprocal identities before we are officially able to solve our equation. So each of these we are going to solve in radians from 0 to 2 pi. And the first example, notice we have a sine and we have a cosine squared. Okay, this is like thinking back to your algebra days. If I asked you to solve this equation, you wouldn't be able to, right? Not everything is in terms of x and y. So in this case, that's kind of the problem here as well. Sometimes we need to kind of convert between the two forms and see if we can get them all in the same trig. And we could do that on this first example because we can substitute in for our cosine squared, 1 minus sine squared. And now everything is in terms of sine. And if we bring everything to one side, we can add over the sine squared. And then we have the 2 sine theta. And then negative 2 plus 1 was negative 1. Add that over to this left-hand side. Now we have a format that kind of looks like our traditional x method factoring, right? A trinomial that we can factor what multiplies to be 1 and adds to be 2, 1 and 1. So it's the same principle that we put x plus 1 and x plus 1. However, the only difference is we now are using sine. So we would put sine plus 1 and sine plus 1. And again, since these are the same, we're only going to have to worry about setting one piece equal to 0. Where is sine plus 1 equal to 0, aka where is sine equal to negative 1? Well, that's going to be when it is down here at 3 pi over 2 radian. Now, in our next example, we again want everything in terms of the same trig. So this time, notice we have a cosine squared, a sine squared. We can make the substitution with the sine squared so that everything is in terms of cosine. So we would have cosine theta equals negative cosine squared plus 1 minus cosine squared on that. And if we bring everything to one side and combine, we have negative cosine squared minus another cosine squared. So we have negative 2 cosine squared thetas. Subtract over this cosine squared to both sides so that everything is on one side. And we want to be careful on this one because notice, if we think about this again in terms of algebra, this time, unlike the last one that was 1x squared, this time we have a negative 2x squared. So we want to be careful with our factoring because it will involve us to group. So what multiplies to be negative 2 times 1, aka negative 2, adds to be our middle term of negative 1. Well, that's going to be negative 2 and positive 1. So if we think about, again, factoring, negative 2x squared minus the 2x plus 1x and then plus 1, we can now group these middle terms. We take out, a negative 2, I don't know, I wrote x twice. We could take out a negative 2x, and we're left with x plus 1. Over in the second group, best we could do is pull out a 1. We have x plus 1. So our two factors would be negative 2x plus 1 and x plus 1. Which again, in the case of this, since we are using cosine, really what we're doing is we're setting negative 2 cosine theta plus 1 equal to 0, and then cosine theta plus 1 equal to 0. So if we subtract over the 1 and divide by negative 2, we end up getting 2 negatives, which will cancel to be where is cosine equal to positive 1/2. And then on the other side, subtract over the 1, where is cosine equal to negative 1. So cosine is equal to positive 1/2 in quadrants 1 and 4. And that's going to occur at pi over 3 and 5 pi over 3. And then cosine is going to be -1 over here on the negative x-axis at pi. Next example is looking at, again, making this all in the same terms. So since we have the sine and the sine squared, our piece here is we're going to change that cosine squared into 1 minus sine squared. Now, please be very, very careful on this one. Notice this negative out front is very important because it needs to be distributed to both the 1 and the negative sine squared to make sure that we properly distribute. So be very careful if you have a negative, especially, or a coefficient out front when you're making that substitution. Because in this case, we're going to distribute that negative through. We end up with -1 plus sine squared theta plus another sine squared theta. And then if we bring over the sine from the other side so that this is set equal to 0, 1 plus 1, we have 2 sine squared thetas. Add that sine from the other side over minus the 1. And what we're going to notice is our factoring actually ends up being very similar to the last problem. What multiplies to be -2 but adds to be 1. In this case, that is going to be 2 and -1. So again, if you think about this as 2x squared, again, we have to be careful because we have leading coefficient there, plus 2x minus 1x minus 1. Group it up. We end up with a 2x we could take out, x plus 1, take out a -1 this time, x plus 1. So 2x minus 1 and x plus 1 are our factors. This time, though, we're just going to substitute back in. Instead of calling it just x, we're going to call it 2 sine of x and then sine of x, or in this case, theta. Now, when we finish solving this out, this time, add the 1 over, divide by 2. We want where is sine equal to 1/2, and then where is sine equal to -1. So sine is positive 1/2 in quadrants 1 and 2 at pi over 6 and 5 pi over 6. Sine is equal to -1 down here at 3 pi over 2. All right, now if we flip to the back, okay, we see that we are switching up, first of all, 2 degrees. We may involve some rounding this time, and we are going to be, again, dealing with a couple more examples dealing with these different trig pieces. So again, we want to be careful anytime we have a leading coefficient out front and if we're making the substitution, because right now we have -3, and again, we have sine and sine. We want to make sure that when we distribute through this 1 minus sine squared theta, right, that we are very careful to make sure that we are properly distributing through. Because what's going to end up happening is when we distribute, we have -3 plus 3 sine squared, and then if we add over this sine to both sides, this ends up being minus 11 sine, and then plus 9. And then break it down one more time. We have 3 sine squared, aka 3x squared, minus 11x, and then -3 plus 9 ends up being 6. So as we factor this time, we want to be very careful because, again, we have a number other than 1 here. So 3 times 6 is 18. What adds to be -11 then? -9 and -2 multiply to be 18, add to be -11. So we have 3x squared minus 9x minus 2x plus 6. And again, this piece is coming from our x method. And then as we group, we could take out a 3x, and we're left with x minus 3. Take out a -2, we're left with x minus 3. And we finally have our two factors, 3x minus 2 and x minus 3. Now, reminder, what's really happening right now is we are setting each of these pieces equal to 0. So we have x minus 3 equals 0, aka sine of x minus 3, or sine theta. And then we have 3 sine minus 2 equals 0. Now for this first part, as we add over, where is sine going to be equal to 3? Well, we know that we cannot take sine or cosine inverse of anything bigger than 1. So what's really happening for this first part is this is actually going to give us no solution, this first factor, okay? The second factor, though, when we set that equal to 0, add over the 2, divide by 3, we want where is sine equal to positive 2/3. So we know that's going to be in quadrant 1 and quadrant 2. Our theta value this time is going to be about 41.8 degrees. Okay, that's our quadrant 1 value and actually one of our answers this time. And then to find quadrant 2, we would just take 180 minus our theta value of 41.8 and get our value here of 138.2. So those would be our two answers. All right, in the second example, okay, again, we must be careful because of that distribution of the negative, because we want to change sine to 1 minus cosine squared, but we have to distribute that negative to make sure that we don't mess this up. So we would actually have negative 2 plus 2 cosine squared theta plus 3 cos. And if we bring over the 1, we have plus 1 equals 0. So we end up with 2x squared plus 3x, and then negative 2 plus the 1 is minus 1. Now factoring this time, again, we have to be careful. We have this 2. So again, when we multiply, it's going to be what multiplies to be 2 times negative 1, aka negative 2, adds to be 3. We ended up with plus 3, and then the minus 2, this is plus 1. So it multiplies to be positive 2, and then we would have 2 and 1. So 2x squared plus 2x plus 1x plus 1. Factor our first group. Take out a 2x, we have x plus 1. Second group, x plus 1. So 2x plus 1, x plus 1. This time, again, we end up actually with exact values from the unit circle when we set these equal to 0. But again, we are using, cosine and cosine as opposed to just x on each of those. So cosine is negative 1/2 in quadrants 2 and 3 at 120 degrees and 240 degrees. Cosine is negative 1 over at 180 degrees as well. All right, our last example together, if we bring everything to one side again, okay, we would have to be careful, this sine squared, everything else is in terms of cosine, so we want 1 minus cosine squared to be substituted in, plus 7 cos theta minus 9, and eventually what's going to happen, distribute, we end up with 9 minus 9 cos squared, and then if we subtract over, we end up with negative 2 cos theta minus 9. This positive 9 and this negative 9 cancel, and we actually are just left with negative cos squared minus 2 cos equal to 0. Now on this one, we don't actually have to x method because we don't have a constant term. What we are going to do instead is take out this GCF, because we can factor out a cosine theta that these both have in common, and we're with negative 9 cos theta minus 2, and now each of these two pieces may be set equal to 0 to solve. So we have cosine equals theta, and then we end up with cosine equal to negative 2/9. Well, cosine is equal to 0 in two spots, right? Up at 90 degrees and down at 270 degrees. And then cosine is going to be negative in quadrants 2 and 3. So we need to find our reference angle. So we're going to use positive 2/9, oops, not 2/3, 2/9. And we get 77.2 degrees. However, we know that the answers actually are coming from quadrants 2 and 3. So we're going to take 180 minus 77.2, and then 180 plus 77.2 to get our final two answers of 102.8, as well as our quadrant 3 value, which was 257.2. All right, thanks everyone for watching. We'll definitely be working more with these in class.